Hello, my dear students. Welcome to my YouTube channel that's Concepts of Chemistry. And before starting today's lecture, please do subscribe my channel and press the bell icon to get the regular updates of the upcoming lectures. My dear students, today we are going to talk about the molecular forces. These are the forces that are present between the molecules, and these forces are different from the ionic bond, covalent bond, and the coordinate bond. These forces are of four types. The first one is ion dipole interaction, second one is dipole dipole interaction, third one is dipole induced dipole interaction, and the fourth one is instantaneous dipole induced dipole interaction. Let's move to the screen to understand this thing with the help of examples. So, we are having four types of molecular forces. Let's discuss about it. The very first molecular force is ion dipole interactions. I'm writing the first molecular force is ion dipole interactions. As the name suggests, it will be the interactive force between the ion and the dipole, or we can say the polar bond. For this case, I'm taking the example of NaCl dissolved in water, or we can say the aqueous NaCl. I'm taking its example to be aqueous NaCl. Aqueous means dissolved in water. So I'm drawing the structure of H2O molecule now. That's the oxygen, hydrogen, and the hydrogen. Now, as we all know that the electronegativity of oxygen is greater than that of hydrogen. So oxygen is going to attract shared pair of electron towards itself. Thereby oxygen will acquire a delta negative charge and hydrogen will acquire a delta positive charge. So we got the first polar bond, and dipole is the another name of polar bond. So I'm going to name it as dipole. Now NaCl is broken down into its ion in the water. So I'm writing Cl negative over here and Na positive over here. So in this case, we got the two ions, the Cl negative ion and the Na positive ion. Now, this Cl negative ion is going to form interactive force with the hydrogen with a delta positive charge of the dipole. So we got the first interactive force, that is between the Cl negative and the hydrogen acquiring delta positive charge of the dipole. So we got the first ion dipole interaction. Now on the another hand, we got the interactive force between the delta negative charge of oxygen and the one positive charge of Na. So that's also the ion dipole interaction. Here ion is Na positive and dipole is OH polar bond. So that's the example of ion dipole interaction. Hopefully you have understood that. Let's move to the second one. The second type of molecular force is, the second type of molecular force is dipole interactions. That's dipole interactions. As the name suggests, these are the dipole interactions between the obviously two dipoles, or we consider two polar bonds. And for this case, I am taking the example of hydrogen chloride. So let's draw a structure. That's H bond Cl, and another one is also H bond Cl. Now, we all know that electronegativity of chlorine is greater than that of hydrogen. So chlorine is going to attract the shared pair of electron towards itself. Thereby chlorine will acquire a delta negative charge and hydrogen will acquire a delta positive charge. So we got our first dipole. Now, let's move to the second HCl molecule. Here also the electronegativity of chlorine is obviously greater than hydrogen. So chlorine is going to attract the shared pair of electron towards itself. Thereby chlorine will acquire a delta negative charge and hydrogen will acquire a delta positive charge. So in this case, we are going to have interactive force between the first molecule and the second molecule from the poles having the opposite charges. That means here the Cl delta negative of first molecule is going to form interactive force with the hydrogen delta positive of the second molecule, or we can say the second dipole. We got the second dipole. So this is called dipole-dipole interactions because these interactions have been found between the two dipoles. Now let's move to the third one. The third one is dipole induced dipole. Dipole induced dipole. In this case, we are going to have one polar bond dipole, and under the influence of that polar bond, the another non-polar bond will be converted to be polar, and the interactive force will form. Let's take an example. Here I am taking the example of HCl and Cl2, the chlorine molecule. Now, that's the H bond Cl, and that's the chlorine bond chlorine. So in case of HCl, we know that electronegativity of chlorine is greater than hydrogen. So chlorine is going to attract the shared pair of electron towards itself. Thereby chlorine will acquire a delta negative charge and hydrogen will acquire a delta positive charge. On the other hand, chlorine molecule, the Cl2, the electronegativity of obviously both the chlorines are equal. So there will not be any charge separation and it's a non-polar molecule. So first polar molecule is HCl and we are going to call it as a dipole. But Cl2 molecule is non-polar, so it's a non-dipole. But once this non-polar molecule approaches the polar molecule, that's HCl, the polarity will arise in Cl2 molecule also. So in this case, there will be the shifting of charge in Cl2 molecule and it will be shift like this. The chlorine will acquire a delta negative charge, another chlorine will acquire a delta positive charge, and this is the induction of polarity once the non-polar bond approaches the polar bond. So the Cl2 molecule will be called as induced dipole in this case. So that's the induced dipole. So in this case, there will be the interactive force between the delta negative chlorine of first HCl with the delta positive chlorine of the Cl2 molecule. So that's the dipole induced dipole interactions. Now let's move to the fourth interactive force. The fourth interactive force is instantaneous dipole. Instantaneous dipole induced dipole. And for this case, I am taking the example of only Cl2 molecule and I am taking two Cl2 molecules as an example. So that's my first chlorine molecule and that's the second chlorine molecule. So in first Cl2 molecule, there will be the separation of charges, or we can say there is a development of polarity, but just for the fraction of second. That's why we are going to call it to be the instantaneous dipole. Now, in first case, there will be the shifting of charges, or we can say development of the polarity, but just for the fraction of second. So we are going to call it to be instantaneous dipole. Instantaneous dipole. Now, another Cl2 molecule is non-polar, and when the non-polar molecule approaches the polar molecule, so that means there will be a development of polarity in the non-polar molecule under the influence of polar molecule. So that means second Cl2 molecule is also going to have charge separation because of the influence of the first polar Cl2 molecule. So there will be also again separation of charges, delta negative and delta positive, and it is going to be the induced dipole under the influence of instantaneous dipole. So now there will be the interactive forces between the instantaneous dipole and the induced dipole between the poles having opposite charges. That is the delta negative Cl of instantaneous dipole and delta positive Cl of the induced dipole. So we got the interactive force, that's instantaneous dipole and the induced dipole interaction. So I hope you all understood all the four types of molecular forces. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.